Hello dear students, today we can have a discussion on the working of the Pelton turbine, its construction and the working principle. So Pelton turbine, as we discussed earlier, it's a type of impulse turbine. An impulse turbine means you will be having a very high pressure head available or potential energy available. We already discussed like a Pelton turbine will be having a head, initial head at the inlet will be more than 250 meters. So in those type of power generating plants, you can utilize the penstock and the nozzle at the end to convert your potential or the pressure head available into velocity head or your kinetic energy. And at a maximum kinetic energy, your fluid will be striking on the rotor. So the rotor or the runner design will be such to accommodate that high impulse force. Here the runner definitely changes the direction of flow of that high velocity fluid jet, and that will result your runner to rotate. So to explain the explain about the working, we can just refer this figure. So here you can see that you are having a penstock at the left side where the water from the dam or the reservoir is flowing through the penstock. Incoming water will be through the penstock at very high velocity. That is the main point. And you are utilizing a nozzle, that is a diverging or a converging cross section of a nozzle to convert your potential energy entirely into kinetic energy. So your jet of water that is coming out of the nozzle will be at very high velocity or a very high kinetic energy, and that high kinetic energy fluid will be striking over the runner. So here the runner will be designed like it is having many buckets or mounted over the runner. So as the high velocity uh, fluid water jet strikes over the bucket will be pushed backwards. That will rotate your runner, in turn your runner shaft. So that runner shaft will be connected to the generator for power generation. Definitely you will be having a brake nozzle as shown at the top of the figure, where that brake nozzle where you can utilize again the incoming water or a bleed of water from the penstock to stop the runner rotation, to stop your turbine or power generation as well. So you will be having a nozzle, a penstock, incoming penstock, a nozzle, a runner mounted with buckets, and you will be having a brake nozzle, and all together you will be enclosed in a casing. So the casing design is also very important, where that particular casing has to withstand whatever forces generated due to the falling water at high velocity. How you can control the rotation speed of your runner is through a spear valve inside the nozzle. You can see a spear headed valve inside a nozzle, so you can close the nozzle and open the nozzle accordingly, or based on your requirement for power generation. So as we discussed, our main parts will be a runner, where you can see the figures for a runner, where over that particular rotor or the runner you will be having buckets. So presently we are utilizing these type of double buckets with a splitter at the center, where that splitter will be utilized to divide your jet into two equal parts. You can see the first figure on the left side, where the incoming water will be splitted into two, and the water will be flowing outside the bucket. It's actually designed for better efficiency or better absorbing of energy from the impinging water or the striking water. And the major other components are like casing that we discussed, like it is to prevent the splashing of water and discharge of water to the or proper discharge of water to the tail race. The outside valve or outside exit area of the turbine is called as a tail race. And you will be having a braking jet and the needle spear for properly controlling the flow of water through the jet. You can see in the figure shown here, you are having needle valve and the runner. then a small animation to show the working. You can see that water coming out of the jet, and as the water hits the runner, you can see the rotation of the runner, and that runner rotation will be fed to the generator side. So like this you can utilize the um, fluid energy for energy production. um, so that's all about the basic working of a Pelton wheel. And now in the later sessions we'll be discussing on the working of reaction turbines in detail, like Francis and Kaplan. So thank you for now.